Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another wonderful lesson in the exciting world of high school geometry.
Good job. Thank you. Let's do a round of applause, y'all. All right. All right. My students wanted somebody else's voice on there for once, so thank you. I appreciate the help. Oh, no, that's not helping. Okay. So, lesson 2 of parallel lines and proofs. Sorry, no. I said that wrong. Lesson number 2 of transversals in parallel lines. We're only going to have one new concept in this lesson, and even then it's a very minor one. The major point of this is to remind you guys, number 1, of some algebra skills you may not have used in a while. Number 2, to refresh some of the stuff we covered last class period, and just go a little bit deeper into those. So, let's go ahead and get started on it. First off, using this picture, I mentioned last time that our little arrows would show us when we are parallel. In this case, we've got 2 sets of parallel lines. The double arrows mean those 2 are parallel. C and D are parallel. A and B are parallel. So, we got the measure of angle 1 is 9x. Let's go ahead and write that in. 9x plus 6. We've got angle 2 is 2 times 2x minus 3. And angle 3 is 5y plus 14. Now, we got to solve for x and y. Oh, that should say and y. Oh, I wrote 2 times 2x. Okay, thank you. See, this is why I don't do this in front of an empty classroom, because I would never have caught that. All right, 9x plus 6, 2 times 5x minus 3, and 5y plus 14. We seeing any angles that are congruent or supplementary there?
1 and 2 are alternate exterior angles.
Okay, 1 and 2. So if I kind of ignore line D for a second and use A and B as my parallels and C as my transversals, then yes, 1, and I wrote that in the completely wrong spot too. 9x plus 6. 1 and 2 are alternate exterior angles, and what do I know about alternate exteriors?
They're equal.
Equal to each other. So that tells me that 9x plus 6 is equal to 2 times 5x minus 3. All right, now let's start simplifying. 9x plus 6, distribute that, gives me 10x minus 6. Numbers on one side, variables on the other. Subtract 9x from 10x gives me x. 6, I'm sorry, add 6 here. 6 plus 6 is 12. All right, easy enough. Now, what about solving for y? Any ideas? Yes, angle 2 and angle 3 are corresponding angles. So, they are, yes, equal. So that means that 2, well, you know what? I'm going to go ahead and use a distributed version of that so I don't have to do it again. 10x minus 6 equals 5y plus 14. And now, I got to substitute in. 10 times x is 12 from the other side, minus 6. And just to simplify here, I'm going to go ahead and subtract the 14 on both sides, equals 5y. All right, now 10 times 12. What do we got, y'all? 120. 120 minus 6. 114 minus 14. 100 equals 5y, which then gives me that y is equal to 20. Okay, neither of those were too difficult. Here's the real kind of reason I was doing this. I wanted to, number 1, practice some of those skills, but also be able to point out something about this particular picture. I've got 2 sets of parallel lines, okay? There is no direct relationship between the angles over here and the angles over here. Now, while it may be true that the 2 angles that I've highlighted are equal to each other, it's not directly alternate exterior angles. Okay? Because I could do alternate exteriors between this angle in yellow and this angle here in blue. That means that these 2 are equal to each other. However, then I could say that these two are congruent by means of corresponding angles, but you have got to make that additional step in there. You can't just go directly from one yellow to the other. Okay? That'll come in very important when we start doing our proofs at the end of this lesson. Okay? So, any questions about this problem? All right. Example 2. Find the value of x. Any ideas? This one trips people up sometimes.
4, 5, 50, and 200.
You mean consecutive or corresponding? Okay, if that were a complete line, if this line continued all the way across, yes, it would be corresponding, but they don't. It's two separate lines, or two separate rays. So there's, again, no direct relationship between the 50 and the 100 degree angles. Are both of these angles here? So this one here? Is that one 100? No, it can't be, because 50 plus 100, it needs to be 180 degrees as a linear pair. Okay, so yeah, yes, these two are linear pairs, so this one is 130 degrees. And this one is, yes, that one's 80 degrees. And yeah, the vertical one, yeah, this one's 80 degrees as well. Yes, this one's 130, this one's 50, but that's still not helping us make any stabs in towards this angle here. Now, this one's a little bit tricky. Here's what the trick is. We're going to draw in an auxiliary line. We're going to draw in a line there, and yes, I missed it. Let me try to do that better. We're going to draw in another line here that is also parallel. Now, what that does is it creates two more angles. That gives me angle 1 and angle 2. Just label them whatever you want, but I'm choosing 1 and 2. Now, what do I know about the 50 degree angle and angle 1? They're not supplementary. They're corresponding angles, because I got two parallel lines cut by this transversal here, and so 50 degrees and angle 1 are corresponding angles. Therefore, that one equals 50 degrees. Now, what about the 100 degree angle and angle 2? They're consecutive interiors, right? And so consecutive interiors are not congruent, supplementary. Therefore, this one has to be 80 degrees, and x is equal to the measure of angle 1 plus the measure of angle 2, which is 50 plus 80, which is 130 degrees. You will have a couple like that on your assignment. It's kind of a coincidence that this angle ended up being the same as that one. So if necessary, draw on that auxiliary line, and we're good to go. Any questions on that?
Couldn't you just put 80 next to it and then that one would be 80? Do you understand what I'm trying to say?
Yes, but essentially that's not going to end up working because of the fact that this line here, this line, and that line have no direct relationship between each other. So these angles don't have a relationship either. So you got to figure out some way of connecting them, and the best way to do that is with the auxiliary line. Now, there are other ways to do that. Once we get to triangles, and we have some of our triangle theorems and postulates, I could have done it by extending the line this direction, making this 50, making this one 80 because of the 100, or because of that 100, and that 80 are alternate interiors, consecutive interiors, and then there's something called the remote angles theorem, which would get me there, but that's all later on, and we don't have those tools yet, so we can't do it. There are other ways to do it, just with the tools we have, this is the most efficient. Okay. Number 3, find x and y. I'm going to be honest with you. The entire purpose of this problem is to get you to review some algebra skills that you haven't used in a while. All right. What do you want to do first, x or y? Y? Why?
There's 2.
Y squared and 8y minus 15 are alternate.
Yes, these two in yellow are alternate interior angles, therefore they are congruent. So y squared is equal to 8y minus 15. Now, back when you were in Algebra 1, you were given several methods of solving equations that have x squared or y squared in them. Those usually included something like this, where you would graph it and see the place where you got the zeros where it crosses the x-axis. Okay?
Oh, we did that
We're-
on the calculator.
Yeah, you do that on a calculator sometimes. We're not going to do that today. The other way,
I did it.
the other couple of ways you could do it have to do with setting the equation equal to 0. Okay? Set everything equal to 0. So let's get this guy equal to 0. I'm going to move my 8y and my negative 15 to the other side. Give me y squared plus 8y, minus 8y plus 15 is equal to 0. And now you've got a couple options. One of those is what I refer to as the brute force method. This one will work every single time without fail. It will either give you an answer or tell you that there are no real answers. And yeah, that's this guy. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What was that called? Called math, yes.
Algebra.
Quadratic formula. By the way, we're not going to do this today for this problem. I just want to refresh your memory on it. Very important one to have memorized, because that one can come up and can save your little booty on tests. All right? Okay, if you used to have it memorized and you don't have it memorized anymore, okay? There's actually a little song. I can't believe I'm about to do this. Wait. Do you know it?
Goes to the weasel.
I know it.
Please, somebody else do this so I don't have to. I really don't want to sing on YouTube.
Nobody do it.
All right, shh. Wait. Let's do it together. No, I'll just spare it and everything. If you know it, we're going to do it all together. Ready? And by we, I mean y'all. Okay, ready? 1, 2, 3.
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yay, thank you.
Wait, you know how easy that would have made my life?
I know, it changes your life, right?
My math teacher played it over and over again until everyone got it.
All right.
Our math teacher.
Although my question is, what's a more life-changing experience, that song or Slope Dude? Oh, y'all know Slope Dude?
Oh, I know Slope Dude.
I don't know.
Okay, we're going to cover Slope in a few days. I might let y'all watch the Slope Dude video. If you think it's exciting, well, I don't want to discourage another YouTuber, but it's an experience. Let's put it that way.
Yeah.
And it's bizarrely good at making you remember things. Okay, so if this right here is the brute force method, then what we're about to do is more of a finesse approach, okay? What we're going to do, it makes the actual solving process so much easier, but you got to have your skills to do it, okay? We're going to factor this guy. Whenever you have a leading coefficient of 1, we get to just copy down the y's, and we might cover our leading coefficient greater than 1 at a different time. But we've got y's at the front. We got to come out with numbers that are going to make this whole thing work out on the rear positions. We're looking for numbers that multiply to give me positive 15 and add to give me negative 8.
We did a box thing.
Yes, you can use the box method to do this. I'm not going to mess with the box method right now. We can get to it later. So Numbers that multiply to 15, add to negative 8. Yes. Oh, good. You picked out the negatives. Okay. So, 3 and 5 multiply to give me 15, but they add to give me positive 8, which is not what I want. However, negative 3 and negative 5 multiply to negative 15, add to negative 8, we're good. Okay? By the way, the reason we're doing that is essentially unfoiling it. That's what factoring is unmultiplying. Because if you were to have foiled that, y times y is y squared, which gives me this term. Negative 3 times negative 5 is positive 15.
I remember what we're doing now.
And then, negative 3 times y is negative 3y. And then negative 5y adds to give you negative 8y. So, I know, I just gave you all like a brain aneurysm from Algebra 1, right? No, that's not the answer. That's the next step in the process. Okay. Now, from there, we got to decide what to do. Anybody remember? I know, it's been a while since in algebra. Okay, here's the idea. Let's go off to a side calculation. Don't write this down. This is just an example. What if I had x times 97 is equal to 0? What's x equal?
0.
Y. Because in order for two numbers to multiply together and get an answer of 0, one of those two things had better have been 0, right? So, yeah, x has got to be 0 there. What if I flipped it around and I said 97 times, well, what did I do first?
X times 97.
Okay, well, so I said 97 times x. Does that change anything?
No.
No. Beginning, end doesn't matter. What if instead I did this? A times b equals 0.
Either A or B.
Okay, so I got a few options here. I could say A equals 0. It could be B equals 0 or both. All right. So now, that's called the zero product property. Okay? Two things multiply together, give you 0. One of them must be 0. Or one or both. So here I've got two things multiplied together. Y minus 3 and Y minus 5. I'm going to set each of those equal to 0. Yeah, now we're remembering, all right? And then either of those could potentially be an answer. So y minus 3 equals 0, therefore y equals 3. And over here, y equals 5. Now, in algebra, for the most part, you got an answer, and algebra is all just about numbers. Every now and then you do application problems, and so whatever. You got two answers, yay, we're done. However, geometry, every single problem is an applied problem. And so we've got to go back and say, do these answers make sense? Because with these quadratics, it's possible you get two answers, but one of them cannot actually happen inside of the geometric construct you were looking at. So we got to go up here and look and say, will this actually work? So if y equals 3, then this angle here, the top angle, is 3 squared, which is 9. Does that make sense? Is it possible for that angle to be 9?
No.
Now, why do you say no? Are you going off of what it looks like?
Yes.
Anywhere on here did I say anything was drawn to scale?
No.
No. Okay, since things are not drawn to scale, 9 is possible, right? If it was 5, is it possible for this guy to be 25 degrees? Yes. What if, okay, hypothetically, what if x was 15? And then we did y. What if y was 15 and then y squared is 225? Would that make sense for this angle to be 225 degrees?
No.
No. Why not? Okay, and don't get hung up on acute there because, again, things aren't drawn to scale. But maximum angle measure is 180 degrees. And so 225 is bigger than that. That would not be possible. Okay, so it's possible that something weird something weird happened there, and we have to toss out one of those. But since they're both possible, then we can't toss it out. Okay, now that gave me y. Now you've got to deal with x. Well, let's take the case where y equals 3. When y equals 3, well, these two guys add to be, what kind of angles are they? Consecutive interiors add to,
Supplementary.
your supplementary add to 180. So, therefore, we got y squared plus x equals 180. So that gives me 3 squared plus x equals 180. 3 squared is 9. Subtract that gives me 171. Now, is that possible? Is it possible for this angle to be 171 degrees? Absolutely. We also have the case where y equals 5. And so then we got 5 squared plus x equals 180. It's 25. Subtract that over, and that gives me 155 degrees. Again, is that possible for x to be 155 degrees? Yes. So your two answers are when y is 3, x is 171, or when y is 5, x is 155. Okay. Not hard, just been a while. I'm going to dust off those cobwebs. All right. Any questions? All right. Another problem here. Now, this one's just a straight up algebra problem, but it's designed to mimic one that you might get inside of a geometry problem. Because I've got things adding together. Like, for example, what if I had, 2x and then 3y plus 150? Those two would add together to be 180. Okay, that's the reason it's designed this way. Now, when I've got two equations with a brace beside it, that's a system of equations, and we have to solve both of them at the same time. Now, they're only going to have one answer. Well, either one, none, or infinitely many. This particular one will only have one. But strategies, you might remember what the strategies look like. You were given 4 in Algebra 1. Well, most teachers choose from 4. What's the first one? What do you think? Okay, one of those was elimination. Any others? Substitution. Any others? All right, I'll give it to you. Graphing. And the other one was matrices. Yeah, that one's kind of, not as many teachers are teaching it lately. Okay. So, for graphing, your strategy would be isolate y, solve for y, get it into y equals mx plus b form, slope-intercept form, graph them, and then the place where the two cross, that is your xy coordinate pair, that's your answer. Okay? We're not going to do that. Substitution and elimination vary slightly. One of them is most likely used when you have like x equals something. It's easy to substitute. Elimination is when I see something like this, where I've got in both equations the same variable with a different sign. That lends itself very well to elimination. So that's what we're going to do. Now, but before I do my elimination step, I want to get my variables on one side and numbers on the other. So I've got 2x plus 3y is equal to, let's subtract this 150 and I get 30. For the bottom equation, 5x minus 3y is equal to 40. And then yes, that brace is important. Lets me see that's one solid unit. Now for the elimination step, I'm going to add the equations together. 2x plus 5x is 7x. 3y and negative 3y are going to subtract out. And that equals 70. And then divide by 7, x equals 10. Yeah, then go up to one of the problems and substitute in. I'm going to choose this one right here. 2 times 10 plus 3y is equal to 30. So this guy is 20. Subtract that off and I get 10.
3.3.
Then I get 10 thirds, which is 3.3 repeating. There is my answers. I know. People are usually good at one or the other. Sometimes both, sometimes neither. Not always. They're not mutually exclusive, but... All right, any questions on our systems problem? All right. Now your favorites. Proofs.
Oh, yeah.
Only 2 proofs today.
Yay.
Only 2. All right, let's just get this set up for our proofs here. Statement, reason. Let's go ahead and get our given in there. And something I wasn't doing last unit that I probably should have been, I honestly just forgot. I want to start labeling or numbering our statements and reasons. And yes, just like Mr. Jewell showed you, and honestly, you showing me that and reminding me of that is the reason I remembered to do this. It's not going to be that important in some cases, but in other cases it is, because it helps us document our substitutions and our transitive properties. So it's important to number them, and you'll see that at the very last step of this proof. All right, I'm not going to tell you all a direction on this. I want to see if y'all can figure out where to go. We want to show that angle 6 is congruent to angle 10. Any thoughts on what direction to go? All right, what do you got? What are you seeing? Okay, you're saying that 6 is congruent to 12, and what would tell me that? What theorem would I use for that? Not consecutive interiors. Alternate interior angles, okay. That'll give me that 6 is congruent to 10. And then 10 is congruent to 12, all right. How do I know that? Corresponding. That's corresponding angles postulate, okay? And then, once I know that 6 is congruent to 12 and 12 is congruent to 10, I could transitive that thing all the way to the end. Okay, that sounds like a good plan to me. So step 2, angle 6 is congruent to angle 12. And that's by the alternate interior angles theorem. All right, good. Step 3. Yep. Angle 12 is congruent to angle 10, and that's by the corresponding angles postulate. Okay. And now I'm seeing 6 is congruent to 12, 12 is congruent to 10, 6 is congruent to 10 by the transitive property. And this is where these numbers kind of come into play here. Remember how, like, sometimes last unit it was hard to tell which substituting I was doing, what into where, and all that sort of stuff? And I was doing all that crazy highlighting and everything. Well, this is going to take care of that, because all we have to do is now write down that our transitive property, we're combining 2 and 3. Just gives us a little tidbit to say where that property came from. Especially when you do substitution, that can be really helpful. All right, so let's be different this time. I'm not going to QED this thing. I'm going to box it. What about done dude? No, done dude don't count. If you drew the done dude on there on your test and nothing else, that would be wrong. Okay, wait, I got an alternate theory here. Let's see. 6 to 2, 2 to 8, 8 to 10. That would work if you did it properly. It's a few too many steps in my opinion, but it would get you there.
Are you okay with that?
Yeah, that would work. Yeah, so guys, Ryan had a good question. He went from 6 to 2 as alternate interior angles, then from 2 to 8 as verticals, and then 8 to 10 as alternate interior angles. That works. On a test, that would be right. When I was grading that proof on the test last night is when I was grading it, somebody did like 12 steps when you could have done like 4. And a lot of them were not needed. And they went a really back circuitous route to get there, but every single step made logical sense from the ones above it, and he got to the answer. That's fine. Okay? It makes it hard for me to grade, and I'd appreciate it if you didn't do that, but it's right. Okay? So, try to find the most efficient one. If you don't find the most efficient path and you still get there, whatever. Okay? You still figured it out. Okay. 6. Let's set this guy up. Give yourself plenty of room for the statement on this side. All right. Let's see if we can come up with our roadmap here. We want to prove that 7 and 13 are supplementary. So 7 and 13 are supplementary. Okay, would 7 equal 14? Yes, 7 would be congruent to 14. Why? They're corresponding angles. All right, so this right here is corresponding angles. All right? Then what? Okay, could you use the congruent supplements theorem? No. If you go back and read the congruent supplements theorem, it's proving that angles are congruent, not that two things are supplementary to each other. You're wanting to do essentially the converse of it, which we don't have as an actual proof, okay, or as an actual theorem. I wish we could. I wanted to do that at first too, and then I realized no, I couldn't. Yes, ma'am. All right, so now 14 and 13 form a linear pair, which means I'll have to invoke the supplements theorem equal to 180, and then I can do some substitutions in from there. All right, I think I got a basic roadmap here. Let's see what we can do. All right, we said first off, we want to say angle 7 is congruent to angle 10.
14.
Thank you, 14. And that was the corresponding angles postulate. Ew, that was gross. All right, postulates. All right. Then we wanted to say that okay, but first we've got to establish, I guess, okay, no, I'll allow it. Okay, so measure of angle 13 plus the measure of angle 14 equals 180 degrees. Why? It's not the angle addition postulate, it's the supplements theorem. Remember, the supplements theorem says that a linear pair is supplementary. Okay, now it looks like we're wanting to say that substitute this 7 in for the 14, right? There's a problem with that, though. We can't go directly from the angles to the measures. We got to convert first. How do I go and say the measure of angle 7 is equal to the measure of angle 14? Or the wrong number there. Okay. Oh. Don't say it. I kind of have to. My YouTube audience is in suspense. Well, which step is this following from? It's coming from 2, isn't it? 7 is congruent to 14, therefore the measure of 7 is equal to the measure of 14. That's the definition of congruent angles. And now for step 6, we can substitute in and say measure of angle 13. Thank you, number 5. Measure of angle 13 plus the measure of angle. Now, originally I had 13 plus 14, but I must substitute in the 7 in for 14 equals 180. And that is substitution. My pen is acting crazy. And that was where I plugged 4 into 3. And now that 13 and 7 add to 180, what does that tell me?
We're done.
We're not done. There's one more step. Add to 180, what does that mean?
There's supplements.
Yes. Angle 13 is supplementary to angle 7. That is by the definition of supplementary angles. And now we're done. And let's use the swords this time. Woo! All right. So that's it for the lesson. I'm going to go ahead and cut the recording off. And as always, all my YouTube fans, my YouTube viewers, stay patriotic.
Yeah.